So how do we pull this and all the other information that literally is pouring out on the microbiome project and understand where we're going with probiotics? What are the functions of the microbiome in health? Protecting against pathogens, interacting with the immune system, also some digestive enzyme activity and synthesis of vitamins. And where this is important is if we think we are going to modify this with probiotics, probiotics may have effects we're not even thinking about. We do need to think beyond the positive, beneficial effects that I think so many people are focused on, in part because of the definition of probiotics. So this graph is well known, I think, to almost everybody. This came from Jeff Gordon's lab. And basically the idea here was to look at family members in 3 countries and to study their microbiome. And what this basically shows is, earlier I said it was all over when we were age 49 because the mucosal flu vaccine couldn't be used. When you look at the stool, it's all over by age 3. The variability goes down dramatically. So it's in those first 3 years of life that there is a lot of diversity. The data came from people in the Midwest in the United States, people from rural Malawi, and also a relatively, actually a completely isolated group of Amerindians in Venezuela. And I think after age 3, you can also see that people have different signatures in their gut microbiome. So in all the populations, though, the microbiome is stable by about age 3. There are significant differences between the US and non-US, raising all sorts of questions, not only relating to diet and genetics of the host, etc. But what does this mean for those novel therapies of the future? What it may mean is that if we manipulate and bring in probiotics in the first 3 years of life, the impact may be the greatest. That may be the best opportunity. But that needs to be studied, and we've also got to understand there may be long-term negative consequences of that. I'm personally concerned it may be more difficult to manipulate the microbiome in adulthood, but I think that remains an open question. And the role of diet really does need to be considered in probiotic studies, and I think in many circumstances just has not. This slide, which is also probably well known to you, really looks at the variability and why there might be so much variation in those first 3 years of life. Here's the problem. There are so many things that affect what colonizes the GI tract of the baby, relating to the mother, the birth process, and the early feeding, and also probably the excessive use of antibiotics in children. And what we have also learned over time, that as probably a result of the fact that there are so many variables, it doesn't seem too surprising to me that each individual is more like themselves than like anybody else. So what are the implications of this relating to probiotics? It may mean that probiotics are not going to do the same thing in everybody. Certainly in terms of altering organisms that are present in the GI tract and potentially elsewhere as well. But what they may do is have similar effects based on function. And I think the early data from Dr. Fraser's lab does raise some interesting questions in this area. These data I'm sure you've seen before as well. This also addresses that around the body, there are different organisms. I don't think this is a huge surprise. An infectious disease doc would have said this as well. But I think the variability that we understand of the microorganisms that are in each of the locations are important. And we do need to consider the effects on the various sites and the potential for immune modulation in one site versus another. So I think that's another issue we need to consider.